Hello everyone, I'm Dr. Buddhika Lenige. So today I'm going to talk about significant figures. So let's go and find out what are the significant figure rules with some examples. Significant figures are used to express the precision of the measured or calculated quantity. The rules for significant figures that help to ensure that the precision of the measurement is accurately reported in a scientific documentation or in the given question. So let's see what are the basic rules of the significant figures and what are the rules that govern for specific mathematical functions, multiplication, division, addition, and the subtraction. The basic rules for determining the number of significant figures. The first rule is the non-zero digits are always significant. For example, 1, 2, 3, 4, 1234. This number all are not equal to 0. They are non-zero digits. So there are four significant figures. The second basic rule is any zeros between significant digits are significant. For example, 1002. So this is 1002. 1 and 2 are significant figures. The zeros are in between, the sandwich in between. So then we consider the two zeros as significant. So total is 4 sig figs. Next, the basic rule is the leading zeros are not significant like 0.0025. So three zeros are we called leading zero or front zeros. They are not valuable. So we can easily ignore only two significant here, 2 and 5. The next one is the trailing zeros or the end zeros in a number. We can consider they are significant with a decimal place, the decimal point with decimal point, example 50.00, then we can consider last two zeros, trailing zeros, as a significant. Then there are four sig figs in this number. However, the trailing zeros without decimal place, so you can see 1500, no decimal placed here. So without decimal, last two zeros are not significant. So in this number, only two sig figs. So these are the basic rules that govern the significant figures in a given or the calculated number. Let's go and find out other rules for some mathematical operations. Rules for operations. Let's go and find out what are the significant figure rules for multiplication, division, and addition and the subtraction. First, addition and the subtraction. The rule is the calculated number should have the same number of decimal places as the measurement with the fewest decimal place. Or simply the given numbers. There are two given numbers for you, 12.11 plus 0.124. So if you type these two numbers in the calculator, you can get 12.234. So that is calculator answer. But this is not your final answer. Based on this addition and the subtraction rule, you have to consider the least number of decimals in the given numbers. There are two given numbers. The first given number, two decimal places, 1 and 1. The second given number, three decimal places, 1, 2 and 4. So least number of decimals in the first number, that is number 2, two decimal places. So then final answer should have two decimals according to the least number of decimals here. So 12.234 we can round it to 12.23. Then two decimals, the final answer. The next rule for both multiplication and the division. So here the result from the calculation should have the least number of significant figures, not the decimal places, least number of sig figs compared to the given numbers or the original numbers. So your calculation here is 4.56 times 1.4. So if you type this in a calculator, the answer is 6.4. So you can see the first given number 3 sig figs, second given number 2 significant figures. So 3 and 2, the least number is 2. Then final answer you need to round it to 2 significant figures, 6.4. I hope now you have a clear idea about there are five basic rules and there are two rules for multiplication division, one rule, and addition and subtraction, another rule. Next slide, let's go and find out some examples that apply these rules. Rounding rules. So before we move on to examples, talk about the rounding rules. If the digit to be dropped is less than 5, the last retained digit stays the same. 3.742 as example, there are 4 sig figs. So now this number you need to round it to 3 sig figs. So 3.742 is our immediate digit need to drop. So 2 is less than 5, so we can easily ignore. So 3.742 become 3.74. Next, if the digit to be dropped is 5 equal to 5 or greater than 5, the last retained digit is increased by 1. Or in other words, before it drop, you need to add 1 to the last retained digit. Let's take example. 3.746. There are 4 sig figs here. So this number you need to round it to 3 sig figs. So the immediate digit to be dropped is 6. 6 is greater than 5, so add 1 to the left. Then 3.74 become 3.75. This is 3 significant figures. Let's fill this number quickly. So first column, original numbers given. The second column rounded to 2 places, 3 places, 4 places and 5 places. The first number to be dropped is number 2. You can see in red color. When we rounded this number into 2 places, the first digit is number 2. So number 2 is less than 5. So we can easily ignore starting 2, 5, 3, 7. All 4 numbers we can drop. So the answer becomes 63. The second number, we need to round it to 3 places. That is 63.2. Starting 5, we need to drop. So 5 is the immediate digit to be dropped. It is equal to 5. So equal to 5 or greater than 5, we need to add 1 to the left. Then 63.2537 becomes 63.3. Third one, 63.2537, we need to round it to 4 places. So 4 places starting 6, 3, 2, 5. So 3 is the digit to be dropped. It is less than 5, so we can easily drop 63.25. Last one, the same number is rounded to 5 places. So if we count from left to right, 5 places, 6, 3, 2, 5, 3. Starting here, number 7 is the first, the immediate digit to be dropped. It is greater than 5. So greater than 5 means we need to add 1 to the left. Then it becomes 63.254. I hope now you have idea about the basic rules of significant figures and how we can apply rounding rules. Let's go and find out some examples. Problem solving. So determining significant figures. How many sig figs in this given number? We discussed the front zeros are not significant. So starting 4, 4, 5, 2, there are 3 significant figures. 500.0. So there are trailing zeros, however, with decimal place. Therefore, we can consider the last 3 trailing zeros as a significant. So total 4 significant figures in this number. And let's talk about addition and subtraction examples. The first addition is 15.67 plus 0.053. So can remember the rule is the least number of decimal places compared to the given numbers. The first given number 2 decimals, second given number 3 decimals. Then final answer you need to report into 2 decimal places. This is calculated answer, and then after it rounded to 2 decimal places, 15.72. This subtraction 98.6 minus 0.34. So the calculated answer is 98.26. Let's go and find out decimals. The first given number 1 decimal, second given number 2 decimal. So 1 is the least, then final answer we need 1 decimal place. So the number rounded to 98.3 because the 6 rounded into left, 98.26 becomes 98.3. Next, multiplication and the division. So 4.56 times 1.4. So calculator is giving 6.384. So multiplication and the division, I can remember the rule is least number of significant figures, not the decimal, sig figs. So first given number 3 sig figs, second given number 2 sig figs. Then final answer should have least number 2 sig figs. Then 6.384 starting 8 we need to drop, but 8 is greater than 5, then we need to add 1 to the left, 6.4. Next, a division. 123.4 divided by 2.0. So here again the same rule, least number of sig figs. The first number 4 sig figs, the second number with this decimal point there are two significant figures. So the given number, the least number of sig figs is 2. Then the calculator answer 61.7 becomes 62. Because 7 is greater than 5, we need to add 1 to the left. 61.7 becomes 62. I hope now you have a better idea about significant figures, how we can apply sig figs rules, basic rules, and mathematical operations rules for examples. Thank you all for watching. If this is helpful, please subscribe the channel and comment any specific area if you need to discuss in the future.